Hi everyone, this video will show you how to get the greatest common divisor between two or more numbers. The greatest common divisor is usually written as GCD A comma B, where A and B are the two numbers you want to find the greatest common divisor for. Now before we get to greatest common divisor, we should know what the division algorithm is. It's simply A equals QB plus R, and Q here means the quotient and R means the remainder. So if we put this in an example, if we let A equals 51 and B equals 10, the quotient should be Q equals 5 and the remainder should be equal to 1. So this is the key formula that we need in order to get the GCD. So this is how you get the greatest common divisor. First, we start off with the same formula, A equals Q1B plus R1. So it's the same formula except that we added, instead of Q and R, we write Q1 and R1. Now, if the remainder R1 is equal to 0, then GCD A comma B is directly equal to B. However, if the remainder is not equal to 0, we simply do the division algorithm again. So here we have our first formula. If R1 is not equal to 0, we do the division algorithm on B and R1 over here. And so if we apply division algorithm, we have B equals Q2R1 plus R2, where R2 is the new remainder. And so now we repeat this pattern. We check if R2 is equal to 0. And if R2 is equal to 0, then the greatest common denominator will be the last remainder that is not equal to 0. So in this case, it will be R1. However, if R2 here is also not equal to 0, then we apply the same pattern again. So this time we get the division algorithm for R1 and R2. And now we plug R1 in here. R1 is the new A and R2 is the new B. So the formula would be R1 equals Q3R2 plus R3, where R3 is the new remainder. And now this pattern will keep on continuing until we have a remainder that is equal to 0. And we'll call that remainder Rn. And this will be the formula where here Rn here is equal to 0. And whenever the remainder becomes 0, we look at the previous remainder that is non-zero, and that is the greatest common divisor. So here it will be Rn minus 1. So now let's look at the example. So if we're given a question of greatest common divisor between 1, 2, 3, 4, comma 5, 6, 7, 8. So here 5, 6, 7, 8 would become A, and 1, 2, 3, 4 is B. So just like the previous example here, we'll apply this pattern, and we have 5, 6, 7, 8 equals 4. 4 is Q1. 1, 2, 3, 4 is B. 742 is R1. And now since R1 is not equal to 0, we apply the same formula again. So how we get this equation is because we apply the division algorithm for 1, 2, 3, 4, and 742. And the new remainder will become 492. 492 is not, the new remainder is not 0, so we keep on applying the same pattern. And this trend will keep on continuing until we get here, where we find 8 equals 4 times 2 equals 0. And this 0 here would be Rn. And this number here, 2, is R minus 1. And so is this 2. So from above here, we see if Rn equals to 0, the greatest common divisor will be equal to Rn minus 1. So the last remainder that is not 0. And in this case, it will be 2. So for this question, the greatest common divisor will be equal to 2. So this is an example where it wants you to find the GCD of 3 numbers. Now you can do this problem just like the previous question. First, you can split this equation into 2. So we can find the GCD between 2 and 6 first, and then from that answer, we get the GCD of that answer and 17. Or we can find the last 2 numbers, GCD, and then compare with 2. So if I do this question, the GCD of 6 and 17 is 1. So we write 1 here, and we get GCD 2, 1, which is equal to 1. Now here are a couple example questions you can try by yourself, and you can compare with the answers.